Okay, so in this video we are going to look at components of a vector, and we'll do that by looking at a specific example of force. So let's suppose that this is my horizontal plane and I have a box here, and it's my objective to move this box in this direction, and let's call it the direction x from xy plane. So obviously if I want to move this box, then I have to apply some force. So let's take three different forces which are of same magnitude, but they are acting in different directions. Let me draw them. Let me show them by arrows, but let me first clear this. So this is my option A, and this is, let me call this is force A, this is force B, and that is force C, and all of them are equal to, say, 20 Newton. And this angle, let's say this angle is, if we can draw this line parallel to the x-axis, let's say this angle is 20 degree, that angle is 30 degree, and that angle is 50 degree. And just to repeat that, all these forces are equal in magnitude. They are 20 Newton each. Only the angle is different. Now I want to move this box in this direction, in x direction. Can you think about it and tell me which of these forces will be more effective in moving the box in the desired direction? Little common sense will tell us that it's the force A. In option A, the force is making a smaller angle with our desired direction, so A will have more effect in this direction. Yeah. Now this is an important statement, so I'll write it like this, that effect of A in x direction is greater than effect of B, and which is greater than effect of C. Now this effect is known as the component, right? So we can write this statement again by using more technical term, and that technical term is component. I'll say that component of A in x direction is greater than component of B, which is greater than component of C. Yeah. So what we also can conclude from this, that if I am applying this force of 20 Newton, then not whole of that force is acting in x direction. Let me draw another diagram with only one force, and let's look at this box again, and let me say that I am applying, this is my desired direction, x-axis, and I am applying this force, which is 20 Newton. Let's call this force F this time. So from the previous discussion, it would be clear that this 20 Newton here is not fully acting along the x-axis. In other words, only a part of this 20 Newton force is acting along the x-axis. Right? So, which means basically the component of F in x-axis, in the direction of x-axis, is smaller than the F. Right? So the question arises is that if out of this 20 Newton force only a part is acting along the x-axis, then where the rest of force has gone? Let me say one more thing here, that the component along x-axis, let me denote that by Fx. So we know that Fx will always be less than equal to F. Yeah. So what is happening is that a part of force F is acting along the x-axis. Where's the remaining part? Because you are splitting this force, we're splitting this force of 20 Newton into one part. We are taking one part out here which is acting along x-axis. So where's the remaining force? Now again, if you use just little bit of common sense, you will see that this force of 20 Newton will have effect along the y-axis as well here. So again, now you got this force F, which is of 20 Newton. It will have effect along x-axis and it will have effect along y-axis. So basically we got two components. So F is equals to Fx and Fy. We are saying that F has been broken into two parts here. Let me scroll it a little bit down. And this thing is known as this statement, that this process of breaking this force F into two components is known as resolution. So how I would say, I'll write this: the force, and this is the technical language that we have to use. The force F has been resolved along two perpendicular directions. So now it has got the force. Let me further add here. The force F has a component Fx, has a component Fx, and another component Fy. And again, just as you split some quantity into two parts, if you add them back together, you should get your original quantity back. This is a simple case. For example, you got a bag of 5 kg of sugar, and you break into two parts, 3 kg and 2 kg. You put those two parts back, and you'll get your 5 kg. Again, you'll get your 5 kg back. All right. The same is the case here. We are breaking the vector F into two components, which means when you add them together, you should get your F back. So this is how we write it: Fx plus Fy should give you your original force F. But here we have to be really careful, because this is not a simple arithmetic sum. It's not an arithmetic sum. It is a vector sum. So we have to write it with these arrows just to denote that these are vectors. So what it says is, if you add vector force Fx with vector force Fy, you get your original force back. Yeah, so here we basically resolve the force into two components, and here we are putting them back together to get our original force back. Okay, now let me draw that diagram again, so that this time we can find the actual value of a component. So this is my box here, or instead of doing that, let me just draw a 2D plane. So this is my 2D plane here. That's X and that Y, and this is my force. Say this is force is equals to 20 Newton again, and this angle is 25 degrees. So if you have this angle given, then you can very easily find the value of components. So in this particular case, Fx, you need to remember that Fx is the component with which your original force, X is the direction with which your original force is making an angle of 25. Fx will be F cos theta, which is basically 20 Newton times cos 25. We can calculate that using calculator. So this is my component of f in x direction, and fy will be f sine theta, which is equals to 20 times sine 25. It looks fairly fair, so we can see that resolving a vector into two components fairly easy, but there is a trap as well. You need to keep in mind that cos will always be with the direction with which you have the angle, with which the angle is given. So here in this particular case, the angle is given with the x-axis, so fx will be cos 25. If this angle is given, so that if this angle is given, then that component in that direction will be cos. Let's take another example to make this clear and to see that there is no confusion. So this is my y-axis, this is my x-axis, and this say is 30 Newton, and this angle is 29 degrees. Now here, because the angle is given with y-axis, therefore fy is equals to 30 cos 29, and the other one will always be sine. So here fx is equals to 30 sine 29. That's all for this.